In this video, I'm going to talk about homogeneous differential equations. In particular, we'll talk about this equation dy over dx is equal to 3xy minus 2y squared divided by x squared. Now, you probably remember the way homogeneous differential equations are defined as follows. Dy over dx is equal to a function that is a function of y over x. That is the definition of homogeneous differential equation. So if you have a differential equation that could be expressed in this format, we call it a homogeneous differential equation. Of course, we are dealing with first order homogeneous differential equation here. And another way of defining the same thing is m of x comma y times dx plus n of x comma y times dy is equal to 0, where m and n both are functions that are homogeneous as well as have the same degree. If that condition is satisfied, then this is a homogeneous differential equation. Now let's go ahead and solve this problem. First, I'm going to just break down the right part. So let's do it. Dy over dx is equal to 3xy over x squared. That's going to give me 3 times y over x minus 2y squared over x squared. That's going to give me 2 times y over x whole square. If you look at the right hand side, this is definitely a function of y over x. Great. Now we are going to go ahead and do the substitution. So let's say v is equal to y over x, or y is equal to vx, and we are going to find the derivative of y with respect to x using the product rule. By the way, is going to be v times derivative of x, which is just 1, plus x times derivative of v, which is just v over dv over dx. Now I'll take this value, that means the right hand side of it, and take this v is equal to y over x and plug it right in here. So dy over dx is going to be v plus x times dv over dx, and that is equal to 3 times y over x, which is v, minus 2 times y over x whole square, which is v square. If I subtract v from both sides, I will get x dv over dx is equal to 2v minus 2v square. Now, if I simplify it slightly further, I'm going to have x dv over dx is equal to 2v times 1 minus v. And we could rewrite it as dv over 2v times 1 minus v is equal to dx over x. Now I can integrate both sides with respect to the corresponding variables. So left hand side I'm going to integrate with respect to v, right hand side I'm going to integrate with respect to x. Now this integral is pretty straightforward. So the left hand side I could just write 1/2, okay. I could actually put this 1/2 on the other side by multiplying both sides, which I may do later on. Let's see. I could have left it right there. That would probably be a little bit easier. But anyhow, let's continue. This I could rewrite it as 1 over v minus 1, then minus 1 over v, okay, and dv. And you can check it out that it works out. It's a partial fraction. So I have the integral here is equal to integral dx over x. Now, if I continue, I'm going to get the following. So it's going to be integral dv over v minus 1 minus integral dv over v is equal to, I'll just actually take this, multiply both sides by 2 so that the 2 goes on the other side. Integral dx over x. And this left hand side is nothing but very straightforward ln, right? Ln of absolute value of v minus 1 minus ln of absolute value of just v is equal to 2 times integral of x, integral of 1 over x dx is just ln of x, and plus some arbitrary constant c. Okay, and in this case I'm going to make my c to be ln of absolute value of c, just to make the expression simpler. So on the left hand side I will have ln of v minus 1 divided by v, right, absolute value of it. And on the right hand side I'm gonna have ln of x square. I should put absolute value here. Okay, so ln of x square plus ln of c, and I could simplify it even further. Ln of absolute value of 1 minus 1 over v is equal to ln of, let's put it, I forget the absolute value here, so ln of x square, okay, x square times absolute value of c. Now if I do that, now I can go ahead and apply the exponential to both sides, exp. Ln and exponential are inverses of each other, so they cancel each other out. It's going to give me 1 minus 1 over v is equal to x squared times absolute value of c. Now v, by the way, is y over x, so it's going to be 1 minus 1 over y divided by x is equal to x squared times absolute value of c. All right, and then I could simplify it further. 1 minus x over y is equal to absolute value of c times x squared, or I could write it as 1 minus absolute value of c times x squared is equal to x over y, right? Then if I solve for y, I'm going to get y, or y of x, is equal to x over 1 minus absolute value of c times x squared. So this should be your final answer. So this is the solution to this differential equation. I hope that this discussion was helpful. Thank you very much.